Okay, good evening students. Today we will see a sample problem in friction. So today we are going to see the condition as two blocks are there. One block is tied with rope and then the blocks are kept in an inclined plane. So this is the given problem. So what should be the value of the angle theta so that 400 Newton block impends down the plane? The coefficient of friction for all the surfaces is 1 by 3. Okay. So they have given two blocks. One is 400 Newton, that is, and another block is 150 Newton. The 150 Newton block is tied with the rope with the support, and then you are having an inclined plane with an angle of theta. So they are asking us to calculate the value of theta. The condition they have given is it's about to slide or about to move. There is impending motion they have given. So according to that condition, we are going to solve this problem. So like previous, we are going to draw the free body diagram of blocks. So this is the given problem. Here we are going to take the first one, 150 Newton block. So I have taken a parallel line of inclined plane and then perpendicular with respect to the inclined plane for reference. Now the weight of the block is 150 Newton, and because it's tied with the rope, so obviously there will be a tension. So I have taken a tension towards right, and then because the tension is acting towards right according to the inclined plane, so obviously the frictional force will act towards left, okay, according to the inclined plane. Because of this 150 Newton weight, okay, there will be a normal reaction of the block, 150 Newton block. So I am taking it as N1. So we have already discussed the normal reaction will be perpendicular to the plane. So here it is perpendicular to the plane, that is N1. The angle which is made by 150 Newton with respect to the vertical is theta. So if suppose you are having doubt that how you have got the theta there, that is 150 Newton force which is having an angle of theta with respect to the vertical line, means I can explain with a brief presentation. So you can see here I am taking PQ as an inclined plane and the horizontal line PR. So the PQ inclined line is making an angle of theta. So now I am taking another parallel line with respect to PR at any point in this inclined line. So obviously we have discussed this one. So this angle also will be theta. So now I am going to draw another line which is perpendicular to PQ, that is CD. The intersection of these two lines, that is PQ and CD, is I am taking it as O. So now we know that the angle between C and Q will be, that is the angle between the line PQ and CD will be 90 degree. If I want to calculate this particular angle, so obviously the CD line is a straight line, its included angle is 180 degree, and then you know that in CD you are having a 90 degree, that is COQ, and then you are having theta, that is QOD. If I want the angle of BOD, then it is 180 minus 90 plus theta. So based on that, 90 minus 90 plus theta is nothing but 90 minus theta. So now I want to calculate the angle of DOE. So I have drawn a vertical line OE. So now if I want this particular angle, so I BOE is 90 degree. So I can write 90 minus 90 minus theta is nothing but it is equal to theta. So again I will repeat this particular step. So we know that BOE is nothing but a 90 degree angle. So BOE included angle is 90 degree, and we know that BOD is 180 minus 90 plus theta. So if we are calculating, it will come 90 minus theta. So if I want the angle between DOE, then I have to calculate 90, that is BOE is 90, and then the angle of BOD is 90 minus theta. So if I'm substituting, I will get this particular value as theta. So in an inclined plane condition, so obviously the normal reaction will act perpendicular to the inclined plane. So whatever angle the inclined plane is having, the same angle the normal reaction also will have with respect to vertical line. Okay, that is one point. Second one is, if I am drawing another line, that is OF, then the angle of theta will be here. Okay, so the COF angle will be theta. So this is the way. Here also we are getting the 150 Newton is having an angle of the inclined plane angle theta. Okay, so slowly you can draw and then you can practice so that you will come to know the relations of angle in the inclined plane. Okay, now we are moving to the 400 Newton block. Again, we are taking with respect to the inclined plane, the horizontal and vertical reference. And we know that the weight of the block is given as 400 Newton. And as discussed now, so this value will be theta. Because of this 400 Newton, so the reaction force of the 400 Newton block, the normal reaction of the 400 Newton block will act perpendicular to the inclined plane. So I have taken N2 here. So after that, the block is sliding towards left. So obviously the frictional force will be towards right. So that we have given as F2. So after that, we have to take the reaction and force component of block 1. So N1 and then the frictional force, because the block 400 Newton block is moving towards down. So obviously the frictional force will act up. So F1 and F2 will act up. So now we are going to calculate the unknown values. So free body diagram of 150 Newton block is there. So you know this is 150 Newton and then the normal reaction 1 and this is the tension, and because the tension is towards right, so obviously F1 will be towards left. So now we know that it is about to slide or impending motion condition is given. So equations of equilibrium we are going to use. Again I want to say that we are going to resolve the forces along the plane. So the first condition, you know that summation of forces along x direction is equal to 0. That is, with respect to the inclined plane, the x direction, that all the summation of forces is equal to 0. And we are taking towards right is positive in the inclined plane. So the first one is, if we want a 150 Newton, so we are going to resolve with respect to the plane. So obviously the 150 Newton will have a two component, that is, with respect to inclined plane, the vertical value is 150 cos theta, and then the horizontal value that is parallel to the inclined plane is 150 sin theta. So now, if we are considering the free body diagram of 150 Newton block, so we are having forces, tension is there, frictional force F1 is there, and then 150 sin theta is there. Acting towards left is negative, and acting towards right is positive according to the inclined plane. So T will be positive 150 sin theta and F1 will be in negative. So now we are writing an equation T minus 150 sin theta minus F1 is equal to 0. So based on this, we can substitute F1 as mu into N1. So mu is given as 1 by 3. So simply we can substitute. So T minus 150 sin theta minus 1 by 3 N1 is equal to 0. So we are taking this particular relation as first equation. Okay. So after that we know the second equation of equilibrium, that is summation of force vertical or y direction is equal to 0 with respect to the inclined plane. Again we are taking upward is positive with respect to the inclined plane. So now if you are seeing the diagram, you are having normal reaction 1. N1 and 150 cos theta. So these two forces we are having. So N1 is acting towards up with respect to the inclined plane and 150 cos theta acting towards down with respect to the inclined plane. So if we are substituting N1 minus 150 cos theta is equal to 0 because we have taken upward as positive. So now the value of N1 is equal to 150 cos theta. We are taking this particular relation as equation 2. Once we have got N1 is equal to 150 cos theta, we are substituting the equation 2 in 1 so that we will get the relation t minus 150 sin theta minus 1 by 3 multiplied with 150 cos theta is equal to 0. And we got the third equation as t is equal to 150 sin theta plus 1 by 3 150 cos theta. Okay. So we did not get any values, numerical values here for the tension or in the normal reaction one. So we are moving to the next block, that is 400 Newton block. So free body diagram of 400 Newton block we are going to see. So this is the free body diagram. So the weight of the block is 400 Newton and it is having a normal reaction N2. The angle between the normal reaction and the weight is theta. Because the block is about to slide in the inclined plane, so the frictional forces are acting towards right with respect to the inclined plane, and then you are having the block 1 normal reaction, that is M1. We are going to substitute equations of equilibrium because the block is about to move, that is impending motion. It did not move, so we are taking it as the block is in equilibrium. So resolving the forces along the plane as like previous case. So the first one is summation of forces along x-axis or horizontal is equal to 0. So with respect to the inclined plane we are resolving. So here you can see that F1 and F2 are acting towards right. So here the block self weight is 400 Newton. So it will have a two component. So one is the horizontal component with respect to the inclined plane, that is 400 sin theta, and another component will be along the normal direction of the inclined plane, that is 400 cos theta. So now we are resolving the forces along the plane, that is summation of horizontal force is equal to 0 or x direction is equal to 0. So here we can see that F1 and F2 are acting towards right with respect to the inclined plane, and then 400 sin theta is acting towards left. So we can write the equation as F1 plus F2 minus 400 sin theta is equal to 0. F1 plus F2 is equal to 400 sin theta. So we can substitute F1 and F2 in terms of mu and n. So 1 by 3 n1 plus 1 by 3 n2 is equal to 400 sin theta. So in this equation we can take 1 by 3 as common, so it will become 1 by 3. So if we can take 1 by 3 as a common, so it will become 1 by 3 multiplied with n1 plus n2, and then we have already calculated n1. We can substitute that value so that we will get 1 by 3 of 150 cos theta, that is n1, plus n2 is equal to 400 sin theta. This particular relation we can take it as equation number 4. The next equation of equilibrium is summation of forces along vertical direction, otherwise y direction is equal to 0 with respect to the inclined plane. We are assuming that upward forces are positive with respect to inclined plane. So here we can see that the forces 400 cos theta is acting towards down with respect to the inclined plane, and then the normal reaction N1 also acting towards down with respect to the inclined plane. The normal reaction N2 is acting towards up. So N2 will be positive and N1 and 400 cos theta will be negative according to our assumption with respect to the inclined plane. So the equation will become N2 minus N1 minus 400 cos theta is equal to 0. So we know that N1 is 150 cos theta, and we can substitute that here. So it will become N2 minus 150 cos theta minus 400 cos theta is equal to 0. So from this N2 will be equal to 550 cos theta. So we are taking this particular relation as equation number 5. So if we see the equation 4, the value N2 is there. So in equation 5 we have calculated N2 in terms of cos theta. So I think we can substitute equation 5 in 4 so that we will get the relation 1 by 3 of 150 cos theta plus 550 cos theta, that is N2 value, is equal to 400 sin theta. So from this, we will get in the left side 233.33 cos theta is equal to 400 sin theta, and we know that sin theta by cos theta is equal to tan theta, so that we can write it as 233.33 by 400 is equal to sin theta by cos theta. So as I said, it's tan theta is equal to 0.583. And then we can calculate theta, that is theta is equal to tan inverse of 0.583, and we will get the value. Theta is equal to 30.24 degrees. So now you can practice this problem. It's similar to the previous, whatever we have discussed till now. So what should be the value of the angle theta? So that motion of the 250 Newton block embeds down the plane. Okay. The coefficient of friction for all is 0.4. And one more thing, they asked you to calculate the tension in the rope. So we have already calculated the relation with respect to the tension and theta. So after calculating the theta, I think we can substitute the value of theta in that relation so that we can calculate the tension in the rope. Okay. So hope you will do the problem and then you will put the answers in the comment box. All the best. Thank you.